morning all. I think all protocols observed, and thank you for your attendance. A warm welcome. So, and today, just to give you a brief introduction on how we're going to structure the presentation that we've got is, so Telikom is a state-owned telecommunications company working both on the mobile and the fixed business. But specifically, we've been doing some proof of concepts looking at satellite connectivity in partnership with Michael and the Skytel team. So what we're going to do today is just have a look at firstly a technical part in terms of what the satellite is and what it does and what the Skytel company does for Telecom in partnership in PNG, and then look a little bit closely at a case study that we've done trying to solve a problem. I think what Ronald and what Lorna are talking about as well is if we know we've got stable and reliable connectivity, there's so much we can do in the digitization side to it. So we need to get to that first hurdle in terms of having that strong, good, fast communication, whether it may be on voice or on data, in this case specifically in the data side to it. And then from that side is Pandora's box in terms of what it can open and problems it can solve from education, healthcare, agriculture, and transformation for all as well. So we'll start the presentation off just with Michael, with the company and a bit about the technical side to it, and then I'll go through to the second stage with the proof of concept in terms of what problem we're trying to solve and how we've actually looked at the concept solution. Thank you.
Thanks, Mark. Appreciate the introduction and the opportunity to speak with you today about how satellite connectivity can support investment in Papua New Guinea. I'll start off with a bit of a pitch just to tell you about what Skytel is and how we fit into the ecosystem. So Skytel was founded in 1995. Originally, we started working out in the Solomon Islands. Skytel is owned by our parent company, Avcom Space and Defence, which was established back in 1981 and based here in Sydney. It's a second generation family business founded by my father. We've been working with Telikom for the last couple of years on some pretty exciting projects that we'll be briefing you on today. Fundamentally, the purpose of setting up Skytel, it was founded to help companies and organisations and government departments navigate the complex and often baffling world of satellite communications. Our mission is to demystify satellite communications with a focus less on the technical side and more on solving the problems to connect more people to the internet and to the digital economy. I'm sure, as most of you in the industry will have experienced, when you talk to a geostationary satellite operator, they will tell you that geostationary satellites will be the panacea to all your solutions. The same for LEO, the same for MEO. Companies who own satellites that operate in Ka band or Ku band or even C band will tell you that whatever their solution is, that will solve the problems of your business today. And frankly, that's not true. We know that we all need a mix of technologies to solve the connectivity challenge of the customers, depending whether they live in the most rural and regional communities, whether they live in the cities. At Skytel, we don't own any satellites. We don't own any orbits. We don't have any frequency allocations. And so therefore, we're free to recommend to our customers what the best technical solutions are to solve the connectivity problems. And that's fundamentally the premise of what we bring. We can buy from all the different satellite operators that are out there, and then we can pick and choose without being hemmed by what we own or what we've got to sell over a particular region. So if we look at the question, how can satellite connectivity support investment in PNG? I think to start, we need to look to the world for examples on how satellite technology has driven investment. Just as the oceans were once used to trade spices, silks and precious metals, space is now used to trade an increasingly precious resource, and that's information. Satellite communications has revolutionised the way we transmit information, enabling instantaneous communications across the globe. The shift from the physical trade to the digital economy opens unprecedented opportunities for countries and companies who embrace it. So to answer the question, how can satellite connectivity support investment in PNG, I think we first need to establish the value of satellite communications, or just satellites in general. And a good way, someone told me, to figure out the value of something is to imagine what life would be like without that technology or without that activity. So I would like everyone here just to imagine what the world would be like without access to satellite communications, satellites in space, just for 24 hours. Oh, maybe I've gone one too far here. Business owners would be unable to access digital payments or take digital payments. Online banking wouldn't be accessible, leaving only cash economy as the only way forward. But of course, how would you access your cash from an ATM that's connected by a satellite terminal if there's no more access to space? Heavy industries like oil and gas that are dependent on GPS precision technologies would be stranded, leading to significant financial losses. Industries like aviation would lose access to navigation and weather information, crippling their ability to fly out to the most remote provinces and to serve those communities. And emergency response teams wouldn't be able to communicate with people out in those regions where there could be a disaster or people would need help. Space is absolutely critical to underpinning the global economy, and particularly the digital economy, which we're all so motivated to kind of roll out into the populations. I'll get a little bit technical, but I'll try to keep it high level for the minute, just to talk about what is satellite communication, what are the different orbits, and how do they play into things today. Fundamentally, we can divide satellite communications into two categories. There are geostationary satellites, which orbit relatively in a fixed position relative to an observer on the Earth, and then there are non-geostationary satellites, which incorporate everything from low Earth orbit, medium Earth orbit, polar orbit, sun-synchronous orbits, and a whole bunch of different elements. In the past, geostationary satellites were the only option for telecommunications companies, and these satellites orbit at around 36,000 kilometres above the Earth, meaning a signal that travels to a geostationary satellite has a round trip of about 70,000 kilometres, and travelling at the speed of light, that translates into around half a second to 0.6 of a second delay, which we call in the industry latency. Geostationary satellites were fantastic at covering broad areas, so great for things like television, things for radio, for Earth observation, for weather data, for emergency services like emergency locator beacons, and for satellite phones. But the industry has reinvented itself of recent times with these non-geostationary orbits, and for the purposes of this presentation, I'll be specifically talking about LEO, but by no means does that mean that's the only solution out there. LEO satellites orbit much closer to the Earth and relative to the observer on the ground, orbit fast across our heads and require far more sophisticated tracking antennas to look at them. The constellations need hundreds or thousands of satellites to provide coverage over a region or over the globe, but they're far more better suited to real-time applications. Things like video conferencing, online banking, digital payments, as well as access to cloud services like cloud-based accounting services and enterprise resource planning services. And right now we've seen, or over the last couple of years, we've seen a revolution in low Earth orbit. The commercialisation of low Earth orbit has happened faster than anything else that has happened in space, with companies like Planet Labs, OneWeb, Starlink, and now the latest kid on the block, Amazon Kuiper, launching hundreds and thousands of satellites into low Earth orbit. And it's no wonder that LEO has become such a dominant force in discussions at industry events like this. The revolution of satellite communications in orbit fundamentally means that it's now cheaper to connect more people to a faster, a lower latency environment. Looks like the slides are out of order, or not even the right. Okay, different slide deck. So as I talked about in the beginning, we had geostationary satellites, and the signals needed to travel about 70,000 kilometres to go from point A to point B. That took about half a second to 0.6 of a second. And when the new technologies of, or rather new technology of submarine cables became commercially viable, connecting two places was signals simply travelled at a shorter distance. If you talk about the Coral Sea cable, it's kind of roughly in the 4,000 kilometre distance. It's obviously a lot shorter than going by a geostationary satellite and coming back down. And so hence, a large amount of traffic moved towards those technologies. But the revolution in low Earth orbit now means that satellites orbit at a much lower altitude in the realm of 1,200 kilometres. And so now, to connect 2 points on the Earth using low Earth orbit satellites, in not all, but in many scenarios, is a shorter distance for that signal to travel, and therefore represents a lower latency link. Another science fact I'll geek out on for a second is that all RF signals, all telecommunications signals, travel at the speed of light. And as we all learn in high school, you can't go faster than the speed of light. But of course, the speed of light can travel a bit slower when it's running through a medium, like that of a glass fibre. And so a signal travelling the same distance through a satellite versus a fibre, with the satellite link, the signal will actually arrive faster or sooner. And the distance is about 30%, which over long distances can make quite a difference. So not only are the satellites now closer, providing a shorter path, the signal actually travels faster through them, or rather slower when it goes through fibre. So the takeaway that I want everyone here today is that LEO satellite is a faster option to traditional fibre in many scenarios, and therefore makes it more relevant to come back into the discussions when we're talking about connectivity. And particularly when you consider on top of that LEO satellite terminals are far lower cost, they use considerably less energy and are much easier to deploy, they need to be considered as a very high priority on how to connect some of these remote and regional communities to change the cost dynamic, the business cases, to deliver the same level of service out into the provinces that we have here in the cities. And we've done some in-field testing with Telikom, and Mark will talk about the results of that for you now.
Thanks, Michael. Let me just go back to this side of it. So to get to the proof of concept, Michael's taken us through the technology side to it as well. We can see now that the transformation in terms of satellite over the years has given us fibre in the sky kind of feel to it as well. And that's opened up a lot of possibilities for ourselves. So what we went ahead with Skytel, and we tested in the PNG market to say, how would this benefit us? And why would we be looking at satellite if we've got fibre? So a lot of cases over here, just at the specific instances is, one, we have quite a few fibre cuts. Getting fibre to remote locations is sometimes impractical and not necessarily cost effective as well. So, and with the transformation in the LEO satellite side, said, okay, let's set up a proof of concept in the situation. The problem over here is with Department of Finance, and if you know the way that they work as well, is that they run heavy data reports on a daily basis. Upon receiving that report, and when it is completed, they are in a position to analyse what payment and what checks they need to issue to relevant government parties. Without that information being drawn in that day, a check cannot be issued. So the government-to-government facilitation with effective communication, that wheel can turn a lot quicker than it is at the moment now. More so in the rural areas. I mean, we're pretty used to the NCD where you've got fibre and you've got your power stability as well. So what we did, we took out the testing on the LEO side to it, and a couple of the challenges, the power, the vandalism, those that work in PNG will realise in terms of what's going on with those challenges as well. So what we took in this situation was, here we go. In the LEO side to it. So what we did was a proof of concept test. While we're still waiting for approval on LEO technology in the market itself, we've used the time in the meantime to use this one on the left over here is the Kaimeta flat panel LEO, and the ones on the picture on the right hand side, the domes, obviously is the LEO, but a fixed installation side to it. Both using the LEO technology. So we've done tests with these ones. You see at the bottom, we've done in almost a lab test in PNG, and then we've done in Daru on the GEO side to it, and Kupiana we're busy with now as well on the LEO side to it, to have a look at the field testing. But just in the essence of time, what we've done is just to look at the table of reporting, and this is just the basic function that's been done. Is two people from the Department of Finance using their IFMS solution. This is a cloud solution that they're accessing as well. So they need public IP and obviously a fast connection. What we try to do in this test is say they're currently using fibre, and it's through obviously Dataco or ourselves in PNG. What would it look like if we did this on LEO testing to look at the rural areas. And what this table is showing you is the different tests that looking at. You can see the duration of those tests in particular is you're looking at 40, 50 odd minutes. It's a huge report that they run every day. If that report cannot run, they cannot make a decision to issue a check. So while you can do this at the offices in Port Moresby, you can't do it in the regions, and the regions are independent. So there's 2 reports that have been done, and what we're just showing over here is the fibre speeds, the Skytel on the Italian and the Skytel on the Carmeta, looking at the 2 different panels to see whether the terminals have an influence to it as well. So in summary, and just Jeremy and Sam running those reports simultaneously next to each other at the same location, not different times. So what we're trying to prove in the proof of concept, while I just go to our contact details at the end of it here, to the end of the presentation, what the proof of concept has shown is that satellite is stable. And is a very good option to fibre if you've got fibre already, to make sure you've got redundancy. Secondly, if you don't have fibre, have a look at whether fibre and the cost of getting fibre to your areas is worthwhile versus a LEO satellite installation as well for your business. And it depends how many users you've got, how much data you need to send, and what your determination for data speeds would be, whether you're using cloud applications or not. The other situation is all with the power. You see from the side is that what Skytel do provide as well, even though you've got the dish on the side, there is a solar panel that stands next to it that can power that terminal if there are power outages. And the reason why we say this is that most sites have got generators. The generators run out of fuel. If you live in PNG, you go and just get a drum of fuel in a couple of minutes. It may take hours, days, weeks to get fuel there as well. So in the interim, this proof of concept, what it has shown is that satellite is a great alternative, and sometimes as a resilience or possibly a primary side to it. Power solution can be fixed, and when government can support government in a function like this as well, that enables government to support the citizens in a much better format. And if you do have any further questions as well, our contact details are on the slide itself. We are in a booth over here. If not, we have got email addresses if you do seek further information as well. And once again, thanks very much for your time. Hopefully this has been insightful for yourself as well, giving you a bit more in the technical and a bit more of an actual proof of concept, what is actually happening on the ground in PNG. Thank you.